Okay, so we have here a circuit and we're asked to calculate the nodal voltages Vn1, Vn2, and Vn3. So let's start with creating equation. Okay, so at Vn1, so this is the node Vn1, and we will consider all the currents that enters and leaves this node. So from here, the flow of the current is to the right since this is positive, and let's write this at Vn1. So we have 12 minus Vn1 over 1 kilo ohm. Then equate this to all the currents that leaves the node. So this is to the right. So we have Vn1 over 500 ohm and Vn1 minus Vn2 over 2 kilo ohm. Then let's just multiply both sides of the equation by 2 kilo ohm. So we have 24 minus 2Vn1 is equal to 4Vn1 plus Vn1 minus Vn2. Then let's just transpose the negative 2Vn1 on the right side. So this will be 7Vn1 minus Vn2 equal to 24. And this is our first equation. For our second equation, so let's consider Vn2. And as you can see, there is a voltage source between Vn2 and Vn3. So this will be a supernode. And we will not consider this, also the R8, because it is already in parallel with the voltage source. So we'll apply the case of the supernode here. Okay, so we will create the equation considering the current that enters and leaves the two nodes Vn2 and Vn3. So this one is going down and going down also. Okay, and I'll start with Vn1. So at Vn2 and Vn3. And so Vn1 minus Vn2 over 2 kilo ohm, and that's equal to Vn2 over 500 ohm plus Vn3 over 500 ohm plus Vn3 over this one, and this one is in series with each other, so that will be 3 kilo ohm. Then let's just multiply both sides of the equation by 3 kilo ohm. 6 kilo ohm, I mean. So this will be 3 Vn1 minus 3 Vn2 equal to 12 Vn2 plus 12 Vn3, and this will be 2 Vn3. Alright. Then let's just put all the variables in one side of the equation. So this will be 3 Vn1 minus 3 minus 12. So this will be 15 Vn2. 12 plus 2, 14. Transpose, that will be negative 14 Vn3. And this is our second equation. Then next, for our third equation, we will consider the supernode, the polarity of the supernode. So the positive side or the positive polarity is connected with the Vn2 side, and the negative is connected with the Vn3 side. Therefore, our third equation will be Vn2 minus Vn3 is equal to 5. Ayan. So we have three equations, three unknowns. We'll just use the mode 5-2 of our calculator. So this is the calculator technique for three variables, three unknowns. Okay, so you will just have to input A, B, C, D. Okay, A, B, C, D. So A for all the Vn1, B for all the Vn2, C for all Vn3, and D for all the constant. Okay, so let's just put it in our calculator. 7, negative 1, 0, and 24. Then 3, negative 15, then negative 14, and 0. Then for the third equation, we have 0, 1, negative 1, and positive 5. Okay, so Our answer would be, ayan. So Vn1 will be equal to 3.83 volts. Vn2 is equal to 2.81 volts. And our Vn3 is equal to negative 2.19 volts. Ayan. So, these are the answers for Vn1, Vn2, and Vn3. Okay? Okay, so we are asked to determine the value of I1 and I2 in this circuit using mesh analysis. And let's start with assigning mesh currents within this loop. So let's say this is I. Let's use capital letter. Yan. So this will be I1. Okay, I2. This is I3. And this is I4. And we are asked to find this I1 and I2. And as you can see, I1 here. So let's write. I1 is equal to I3 minus I1. Yan. And I2, so this one is equal to I4 minus I2. Yan. So we have to find the value of I1, I2, I3, and I4 first before we can determine the value of this I1 and I2. So let's start with creating the mesh equation. So at I1, so this one, okay, so let's consider all the current that is in this mesh. So we have negative 2 I1, negative 2 kilo ohm I1 minus this one 500 ohm. So we have two current that is flowing through this resistor I1 and I2. Then for 500 ohm, the R9, we also have two currents, the I1 and I3. Okay, so equate them to 0 since we don't have any voltage source in that mesh. Next, let's just simplify this one. So we have negative 2,000 minus 500 minus 500. That is negative 3K, right? That's negative 3K ohm multiplied by I1. Then for I2, we have negative 500 times negative I2, that's positive 500 I2. Minus 500 times negative I3, so that will be 500 I3. Okay, and equate this to 0, and that's our first equation. Then for I2, so this one, so let's say negative, let's start with 500 ohm, the R13. So 500. Two currents are flowing and we have I2 minus I1. Then for R11 minus 1 kilo ohm times I2. Then 2 kilo ohm, also only I2. Then R10 500 ohm. So two currents again. We have I2 minus I4. Then equate them to 0. Now let's just simplify. For I1, we have negative 500 times negative I1. So that's positive 500 I1. Then for I2, we have negative 500 times I2. Then we have this one. So this is I2, negative 3,000 minus 500. That's negative 3.5K I2. This one pa. So we have 1, 3. So we have 4 kilo, no? We have 4 kilo for I2. Okay, delete. negative 4 kilo for I2. Then, we don't have I3 here, but we have I4. And negative 500 times negative I4, that's positive 500. I4 equal to 0. And that is second equation. For I3 and I4, since we have here a current source in the middle of I3 and I4, this is a super mesh, this one. So this is a super mesh, okay? And since it's a super mesh, we will consider the current that's flowing on this loop, okay? So let's start with 12 volts. 12 minus 500, the current that is flowing through this resistor is I3 and I1. So that's I3 and I1. Then minus 500 multiplied by I4 minus I2. Then minus 2 kilo ohm multiplied by I4 and equate them to 0. So we have, for I1, we have 500 I1, then plus 500 I2, then minus 500 I3, then negative 2.5 KI4, and equate them to negative 12K. And that is our third equation. For our fourth equation, so let's just write the equation for this one, for the super mesh. So we have same direction as, it's the same direction with the I4. So this will be I4 minus I3 equal to 10. And that is our fourth equation. And so, since we have four equations for unknowns, we have to simplify these equations first kasi ang kaya lang ni Calcu is tatlong equation. Some Calcu can solve four equations for unknowns, kaya lang yung calculator ko hanggang 3 equations, 3 unknowns lang. So, let's just simplify the equations first. Okay? Okay, since we have four equations for unknowns, we can just simplify the equation so that we will have only 3 equations, 3 unknowns. So, yun yung kaya lang ng calculator natin. If you have 570ES plus like mine or 991ES, so you can solve it by mode 5 too. But other calculators can compute 4 equations for unknowns. And if you have that calculator, so, ayun, you're so lucky to have that one. No? Then let's rewrite the equations first. Okay. We have I1 multiplied by negative 3K. I2 multiplied by 500. I3 multiplied by 500 and equal to 0. Our second equation, that's I1 times 500 minus I2 times 4K plus I4 times 500 equal to 0. Third equation, we have I1 times 500, I2 times 500, then I3 times 500, then I4 times 2.5, okay, equal to negative 12. And our fourth equation, that is I4 minus I3 is equal to 10. Now we can express the I4, the fourth equation, as I4 is equal to 10 plus I3, and we can substitute this equation to equation 2 and equation 3 so that we will have 3 equations, 3 unknowns, I1, I2, and I3 only. Okay, so let's do that in equation number 2 first. So this will be I1 times 500 minus I2 times 4K. Okay, plus our I4 is 10 plus I3 multiplied by 500 equal to 0. So this will be I1 times 500 minus I2 times 4,000 plus I3 multiplied by 500. Then we have 10 times 500, then transpose on the other side. We have negative. 10 times 500 is negative 5,000. Ayan. So this will be our new second equation. Then for our third equation, so we have I1 times 500 plus I2 times 500 minus I3 times 500. Our I4, that's 10 plus I3 multiplied by 2.5k equal to negative 12. So this will be I1 times 500, so I2 times 500, then I3 500. We have I3 times 2.5, so we have I3 times 2.5k. Then negative 12, we have negative 10, this one, times 2.5k, and transpose on the other side, so this will be 10 times 2.5k. Ayan. So our third equation will be I1 times 500. Ayan. And 500 plus 2.5, so this will be I3 times 3k. Then negative 12 plus 10 times 2.5k, that is 24,988. And that will be our new third equation. So we now have three equations, three unknowns with I1, I2, and I3 only. So we can use mode 5-2 or calculator technique, and we can have the answer as ayan, negative 1.427759398 ampere. Our I2 will be 6.315789,474 times 10 raised to negative 4 ampere. And our I3 is equal to negative 8.56718797 ampere. Then to solve for I4, of course, that will be I4 is equal to 10 plus I3. So let's just compute for 10 minus 8.56718797, or I can just use 2 to 3 decimal. Okay, so our I4 is 1.43281,203 ampere. Ayan. But we're looking for values of I1 and I2. Our I1 is equal to our I1, that is equal to I1 minus I3, or I3 pala, I3 minus I1, sorry. So if we will compute, so negative 8.56718797 minus I1, or plus 1.42. Ayan, so our answer would be negative 7.139 ampere. Ayan. And our I2, so our I2 is I4 minus I2. And that is 1.432 minus the I2 6 point, yan, mahaba, raised to negative 4. And that is 1.432 also, since I2 is very small, so it is not, can't be felt. So we have 1.432 ampere.